This is Mr. Beck Does Your Homework, Physics Homework 19, question number 14. A DNA molecule is 2.31 micrometers long. Remember, micro means times 10 to the minus 6th. The ends of the molecule become singly ionized, so there is negative 1.6 times 10 to the minus 19th coulombs on one end and plus 1.6 times 10 to the minus 19th coulombs on the other. The helical molecule acts as a spring and compresses 1.30% upon becoming charged. Find the effective spring constant of the molecule. This is a great problem. Okay, so I know this is the length of the molecule, so I'll just call that L equals 2.31 times 10 to the minus 6th meters. That's how long the molecule is. I know that there's going to be a charge on either end, so I know that Q1 is going to be negative 1.6 times 10 to the minus 19th. Q2, coulombs. Q2 is going to be positive 1.6 times 10 to the minus 19th coulombs. R is actually the distance between those charges, right? This whole molecule, this double-stranded DNA double helix, I wish I could draw a double helix, something like that, is going to be a certain length long. Well, that is how far away my positive charge is from my negative charge, so that is my length. So this is equal to R. And so from these, I could actually find the electrical force between them. So that's going to be K, Q1, Q2 over R squared. That's going to be the electrical force between them. So you can do that already. Now the tricky part. It acts as a spring and compresses 1.3% upon becoming charged. So it compresses that much. That means that when this pulls together, it's going to squish it by some little amount. And that little amount is, as you know about springs, that's X. So your X is going to be, for me, it's going to be 1.3% of the length of the molecule. So for me, it's going to be X equals 2.31 times 10 to the minus 6th times 0.013, which is 1.3%. That'll give me my X. Now I'm looking for the effective spring constant of the molecule. Well, if I have a force, electric, that is also going to be the spring force, because that's going to be the force that the spring pushes back with. So that's X, that's the force of the spring, and I know that the force of the spring is going to be K, the spring constant, not the Coulomb constant, so be careful, you've got two K's here. This is the spring constant times X, so that means that K, the spring constant, is going to be the force of the spring divided by X, which is the same thing as the force electric divided by X. So the force electric you calculate here, the X you calculate there, and that will give you a spring constant for this spring. And enjoy that problem.